I've been thinking about this experiment for a while now. So I wanted to show you guys how I wanted to execute this experiment. But before I do that, I want to tell you what my hypothesis is. My hypothesis is that the 5W30 Valvoline Restore and Protect has some sort of molecule in it that outcompetes carbon and probably is more attractive to some sort of metal surfaces such as chromium around piston rings, for example. So basically what's the setup here is that we're going to take this Valvoline Restore and Protect 5W30. We're going to use Walmart SuperTech 5W30. And we're also going to use, I'll tell you about these two here in a second. Basically what we're going to do is we're going to do what I'm calling a cling test. Now this is not anything I would say is super scientific. There's lots of different ways you want to control. In fact, you'd want to validate a lot of your stuff that you use before you do an experiment. But again, this is just to see if we can get any insight. And in fact, this is more of a feasibility test because I have another test planned if I get some feasible results from this. And I think you guys are going to find this quite interesting. So basically, we're going to allow the oils to sit in their respective oil here for 5 minutes. And we're going to pull them out and we're going to weigh it. And we're going to see which one clings to these metal rods, which one is going to be the heaviest. I've already, again, filled the cups up with oil, as you can see back here in the back. And likewise, I have already pre-weighed the cups here, and these cups over here we'll be using these cups here we'll be using as well, and already pre-weighed everything with the rods. So all of that's done. Now, one thing I just want to reiterate here, this is not anything I would say is scientific, but it might give us some insight on what my expectation is that this one here should cling overall more to the metal rod than the 5W30. So I put 70 milliliters of oil in each one of these containers, as you can see here, and we're going to set the rod in each one and let it sit for 3 minutes, and then we're going to weigh it. Now here's the experimental setup here on paper if you want to pause the video and take a look at that. And that's just that. And the next thing I'll do is I kind of just show you my setup here so you can see what's exactly happening, sort of quote unquote behind the scenes here. So, and actually there are going to be two parts of this test. I'm calling this the ambient part here. Now the next part to the test, after we collect data from this set, we're going to clean these rods off. We're going to re-put them, let me back up a second. We're going to clean these rods off, and then we are going to, I'm going to heat them up with my heating gun here. Now this is, I'll go ahead and admit that this is not the best way to do this. You want to heat the oil up, but again, I'm going to just heat the rod with my heating gun for 3 minutes, let it get super hot, and then I'm going to stick it back in the oil here for 30 seconds to make sure that the heat of the doesn't get too dissipated in the oil. Then I'm going to weigh that. So basically I'm going to do an ambient part to this test and a heated part. So I showed you that, and I'll show you what else I got going on here as well. So I got my infrared camera here, my Topdon TC001. Really good little thing to have around your house. It does a lot in terms of, for example, if you think you got any air leaks, water leaks, anything in your house, this thing actually can find some stuff that's inside of the walls you can't see actually. I've actually found a spot in my house where some sort of connection was wrong. I think it was a shared neutral or something to that effect. I can't remember, but my house was still in the warranty, so I got them people come out and fix it and it went away. And I saw it with this here. Another thing I got going on here is that, as you can see, I got my buddy heater going on. This thing is pretty amazing. I live in North Carolina. I don't know how to fare in super cold weather, but it does me justice. And the reason why I pulled a buddy heater out is because when I first came into my garage, as you can see here, let's see what the temperature is. It is 68 degrees now. When I first came in here, it was about 60 degrees. So I wanted to kind of get everything close to room temperature as possible to make sure that, just so everything wouldn't be super cold. So what I'll do now is I'll go ahead, just for the sake of, let's see here. We'll go ahead and pull out the thermal camera. We'll just go ahead and measure up all the temperatures of the oil and the rods now, so you can see how that worked. So we'll go ahead and start recording that right now. And let's just put that over here. So wait a minute, that's in the way there. My hand was. As we can see, this oil here is about 67 degrees. That's the SuperTech. I'm sorry, that's the Restore and Protect. The SuperTech is about 67 degrees. The 0W20 is about 66, and the gear oil is about 65-ish. So again, they're within a margin of error of the same temperature. Now looking at the steel rods here, they're about 68, 69 degrees. That's for the first one. About 7 degrees for the second one. About 70 degrees for the third one, and about 70 degrees for the fourth one. All right, so we got that done there, so we could take a look at that. I do have everything marked. For example, like we see right here, this is cup 4A. This is for 4 ambient. I have this rod. This rod is going to stay with the set of 4 throughout this whole thing. This right here is number 4. This right here is for the gear oil. This right here, and this cup here is for the ambient test, and these right here are labeled 1 through 4H, and this is for the heated test. All right. So, but before we jump into the test, there's a few things in these books I want to talk about. This book here, this is a fantastic, very old book. I think it was published in 1998. Very good book, really technical, but it has a lot of practical stuff in there. Just about anybody can read it. And I think this right here is even super easy to read. I think if you can get a copy of this, these are really cheap. If you're into oil, get one of these books. In fact, I have a patent coming that I'm going to do a super good video on. And actually, this was a patent written, I believe, in 2018. And they actually cited this book right here. This book was printed in 1980. And one fun fact is that I thought this was amazing. The guy that wrote this book, he got his bachelor's degree in 1939. I thought that's pretty amazing. His name is George Wills. So anyway, let's go ahead and jump into the books now and have a little bit of discussion. All right, so here in the first book, this is in the Friction and Lubrication Mechanical Design book. I just want to show you this about what they speak about surface roughness. And again, it's not really, we got a big discussion. I just want to show you, if you look at this average, I guess, surface roughness in micro inches here. Again, if you look at this right here where it says milling, which is what I think these steel rods right here are, this is the expected surface roughness. So the whole point I'm trying to make versus something that's like polished or something that's been bored out, the surface roughness it has a much less variance in it. The point what I'm trying to show this here is that, again, I just want to say that again, that I don't think that this test right here is necessarily going to be anything super scientific or anything telling. So I just wanted to point out that surface roughness has a lot to do with how things contact, how things grip, and again, it's not even I guess it's more or less in terms of when you talk about fluid films in the engine, you're talking about pressure and heat and things like that. So for example, we go here, we can see that we look at this chart here for film thickness, that being that no change in heat here, you'd have a straight line right here. But as the temperature drops, then the film thickness also increases. So that makes sense. So the hotter something is, the lower the film strength. So again, that's why I wanted to do a heated versus an ambient to see. Again, we should see a difference in the heated, but again, like I said, it's not going to be anything super scientific or technically. We should be heating up the oil, but I'm just going to heat this up just for a quick and dirty test to see if I can get this rod super hot, stick this inside the oil, and then just let it sit for 30 seconds before the heat dissipate to see will less oil stick to this rod. I think that's all. I got one more bookmark here, but I don't really think. Oh yeah, I just wanted to show you that there's some crazy equation. If anybody's out there interested in this thing here, this is the maximum oil temperature here, and that S right here represents the surface. And again, if you think about this being a denominator, this number right here could never be 50 because that would be an undefined division problem there. So that would negate this whole problem. And if it was 50, and everything would just be multiplied times 1. So it's going to be somewhere greater than 0, but less than 50. Probably not even close to being 50. But anyway, as you see, all this stuff plays a part into, in this section here, they're talking about gears here, looks like. But again, as you see, there's a lot more at play when you're really determining how something cleans to something. So again, I just want to reiterate again that this here is just a quick and dirty test just for more or less entertainment purposes. Though you never know, it may tell us something. Who knows? Now, going back over the gears, and I did find this interesting when I was reading this book right here. This one right here. This is Lubrication Fundamentals. It's an ExxonMobil publication. And let's see here. Yeah, viscosity, which is in centipoise here. That, I can't really get the book. I think that's probably about as best I'm gonna get it. Again, you should be able to see it. If you just look at this line here, viscosity, if you look at the pressure right here, as pressure increases, viscosity also increases. So in your engine, so basically what I'm saying is that if you think about gears and you think about, say, cam phases and things like that, changing your oil and keeping fresh, clean oil, basically to have a solid, if you think about a column that has like a straw and it's full of liquid, you got a nice pool of that drink you're drinking, like water, for example. But when you get to the bottom, if there's a little bit of air coming up, you're not getting as much oil. That's not necessarily analogous necessarily to an engine, but it's just to say that, you know, more I read about oil, the more I'm telling you that it's very important to change that oil, particularly anything that's like grinding together like gears. And last thing I want to show you, this is just sort of an interesting take here on something, was that we look here at these gears right here. These are spur gears that you I think would likely find in a manual transmissions or a transfer case. And usually this gear here takes synchro mesh. And so, but that's different if you think about it. So in other words, if you're trying to figure out which type of gear, or say we got a vintage car, you need to figure out what type of gears you have first of all. Then you can see what's oil in the modern day is compatible with it. Because I've seen people in forums asking what type of gear oil should they put in a differential, say a 1960s or 1950s, something. And over here, these are hypoid gears you see here, which is what's in my differential. These right here seem to mainly take a GL5 gear oil, which is what this right here is. So, and they go on in this book to show you a lot of stuff and to really show you these contact points, the leading sides, and how when they spin, you have like oil clinging. So in other words, me reading all of this stuff, that's kind of the genesis why I came up with the idea of how this oil right here, why it might cling, and that in theory, this oil here might cling more to the metal than the SuperTech. I still love SuperTech. I'm going to continue to use it just for the record. So anyway, that's that. So let's pull this book here out of the way and get on to the action and begin testing here. All right, guys, got everything set back up for testing. So the first thing we're going to do is I got my timer right here. We're going to take this rod here and we're going to put it in the oil and lay it like this. So we'll assume that if we lay them all like this, they will all have the same depth in the oil, and we'll begin our timer now. And we'll speed this up and I'll do each one of these and you'll see it. All right, guys, so we're just about down to the wire now. So what I'm gonna do is, I said I was gonna do all of them on camera. What I'm gonna do is I'm gonna just do this first one right here on camera, speed it up, And I'm gonna do the first heated one on camera and speed it up, and then I'll just go ahead and do the rest off camera to keep it simple. Let me go ahead and get this right here, right, set that there. Go ahead and move this over here so as soon as it goes off. And what I'm gonna try to do is kind of pick it up in such a way to not let anything drip off here. All right, so we're gonna try, like a little bit did drip off, but we couldn't help that. I mean, that's just a little bit of variation we got there. Okay, so that weighs 51.67 grams. Okay, got a result. Okay, we'll set that to the side. Let's go ahead and put this one in here. Get the Walmart SuperTech started up. Hit that, and I'll be back shortly with the rest of the data. All right, guys, so I got all the data collected for the first part of the test, and I got everything set up for the second part of the test. I'm just going to wait to the end to show the results. I think that I mentioned earlier that I was going to wash the bars, the steel rods here, with soap and water before heating them up, but I thought it might have been a bad idea because however you clean it, it might leave some residual molecules behind that may disturb any cleanliness. So I just opted to take the blue typical shop towels or shop rags or whatever you want to call them, these right here. And it's wiped it really, really, really clean and kind of just worked it a lot, on each one. So it'd be minimal if any of the oil residue left behind. And if that's the case, then well, that's not so bad compared to say a soap or some other type of chemical residue like from brake clean or something, for example. So now the idea in this part of the video is that we're gonna put this, because I'm using a magnetic tray and I got it set so the angle of this right here is coming straight down onto the rod, and we're gonna leave this heated. I think I should be able to heat for 3 minutes. I want to heat this for 3 minutes with this, and then dip it in here for about approximately 30 seconds, and so long as it's about 3 minutes, because what I'll do is that once the timer goes off, this is the plan. I'm gonna heat this for 3 minutes. Once the timer goes off, I'm gonna set the timer to 30 seconds, then move this into the oil and start a timer for 30 seconds, and then proceed to record the weights. So let me move all of these cups here out of the way first, because these are the old cups. I'm just trying to get everything set up here. Give me 1 second, guys. All right, so I got this back. I probably don't, yeah, you do see me doing that a little bit. All right. So let me get my thermal camera here because I want to get the temperature here to see what kind of, so I'm gonna kind of keep this one rolling. But like I said, like in the first one, we'll do the first one here, and then we'll move on and do the rest of them off camera here. So give me a second here. Let me open up my thermal imager here. All right, we in. So with that said, we're gonna go ahead and turn my ryobi, turn it to high right here. My timer here, give me a second. Wasn't quite set up, I guess, not quite as I thought. Can you see that? Let's see, we set it right here. Y'all should be able to see that. Yeah, we'll set it right there. That should be 3 minutes. Yeah, that's good enough, okay. Okay, we're on 3 minutes. Let's go ahead and turn this to high and hit start. All right, so let me get my thermal camera out. We're gonna go ahead and we're gonna start recording right now. And as we can see, let's see what we got here. Getting about 115 degrees, 120 is stepping up. So it's got the ambient in the middle of the screen. You know what, I think I told you the wrong temperature and all that. So it's about at 200 degrees here floating around. I should have set this, I think I can set this to put the crosshairs on the hottest thing in the screen. So that's what I should have done. So anyway, the temperature is jumping around about 300 degrees, and hopefully, again, I got a couple of ryobi batteries here charging up, so we'll have that, enough batteries in case if this dies here. So anyway, let me go ahead and, well, let me see, is it gonna, what is it gonna plateau out at? Right now it's about 350. It's about 350, 360. I'm gonna test something. I wanna see how hot the rod is over the other end of my hand, so if I have to pick it up, let's see here. Okay, it's not hot here, so I can touch it. 488 degrees. So I don't really know how hot the rod is getting. Again, I'll try to set my scope up. I was trying to set this up differently because I thought I had it set where the crosshairs or wherever you pointed it would be the hottest, but apparently it's just capturing the hottest area, just sort of jumping around doing that, which is okay. We still get a good idea of what's going on here. Because this is going to be about the same for all of them, so that's why it doesn't matter all that much. So let's see what else we got here. We're getting down to the wire, and that's about 1 minute left. We're up to, what is it, about 410 degrees. We'll stick this in the oil here for 30 seconds, and hopefully we get a good result. The other results, I ain't gonna show them to you just yet. They are, I gotta say, just wait and just let's take a look at those together, because you might find them interesting. On the surface, they don't look that interesting, but I think they are interesting because I've seen numbers like this before. And yeah, so I ain't gonna talk no more about that until we get to that. All right, let's see, we're getting down here to about 19 seconds. Get a little closer here. It's about, I'll say about, let's just say on average about 400 degrees inside this tray here. All right, so we're gonna stop this, stop that. Okay, now we're gonna, then we gotta set that at 30 seconds. Okay, then we take this out of the tray here. Ooh, that tray is hot on that end for sure. And we're gonna stick it right in there, hit start. All right, there we go. That's gonna be, let me turn this around here. That's the experimental setup here. And pretty much once this 30 seconds here is up, I'm gonna go ahead and put it back over here. Oops, sorry. Put that back over here on the scale. And that's pretty much, let's see if I can back up a little bit here. Yeah, so you can see that. And well, I'm a little late here. I thought I was gonna be, okay, but that's okay. So now I'm gonna try to turn it up just a little bit so it won't, yeah, some still spilled off. Couldn't help that. All right, so that's it. This weight here was 51.75. Got that weight down. I'll go ahead and do the rest of it, and we'll come back and we'll take a look at the data. All right, guys, this here is the last result. Here's the gear oil here. I think the results are interesting. They're quite interesting. Will they mean anything? I'm not sure, but I cannot wait to take a look at them with you guys. Let me go ahead and get this result really quickly. Okay. Put that in there. The last result, and that is 51.79. Let's go ahead and do that calculation right quick. Do that difference here. 51.79 minus 50.97 equals. All right, so now it's time for the results. So here are the results we got. We're gonna go inside and put these on the spreadsheet as well, and to see and do a little bit of more manipulation with the numbers. But what I found striking is, first of all, let's look up here at the ambient. Although these are only 1/100th of a difference, this had more ambient weight than the Walmart SuperTech 5W30, and then it did predictably what you'd think at ambient, like the 0W20 had less weight, and the gear oil had more weight. That's interesting because, well, you know, you would think that that's how it should go. But take a look at this. Under the heated testing portion here, Valvoline Restore and Protect, again, I'm doing all this manually, nothing's validated. Nothing's calibrated, but still, I did my very best. I do scientific work. I got really good hands in the lab. But take a look at this. Valvoline Restore Protect had 0.34, what you think, okay, that's less because it's heated. That's right. But if you move down to Walmart Restore and Protect, I end up getting a difference of 0.16. Now, at first I said, okay, this is a fluke. Probably just didn't do something fast enough or something manually. Then the 0W20 came out even higher at 0.71. Okay, all of them were done the same way, heated for 3 minutes, set into the respective oil for 30 seconds. Now, the most striking result here is actually, well, not really, because the gear oil is much thicker. The gear oil still has, but still, it has a much higher weight, even, heated grams than which makes sense. It is higher than the 5W30 and the 0W20. They all are really high, but the Valvoline Restore Protect was low. Isn't that interesting? Well, anyway, let's go ahead inside, pop these into a spreadsheet, and just do a little bit of data manipulation to the numbers and see what we can find. All right, guys, so now we're back on the inside here. I got everything popped here in Excel. And, well, looking at, let's go through the ambient temperature test. Okay, this looks, again, although there's only a 1/100th of a gram difference between the Valvoline Restore and Protect versus Walmart SuperTech 5W30. You would, again, my hypothesis was that it should be more clean. Technically, well, I'm sure there's a little variation in the test. This is all done with unvalidated, uncalibrated equipment, but still, you still got a smaller, very minute amount of more of the Valvoline Restore and Protect in terms of grams. Now, moving on to the 0W20, that's a little bit less. Well, and that was expected. I mean, again, these numbers are trending in the right direction for the ambient test. And for AC Delco, there's gear oil 75W30. There's a significant, well, there's a little bit more. It's much more than, say, the 0W20, a little bit more than the 0W30 and the 5W30. Now, these numbers are really close, but at the same time, these small differences could be significant, though. You'd have to, do, probably this at least 30 times before you even can begin to say if these numbers this small, if these little fold changes are significant. But again, I enjoyed doing this experiment and still is expected. All right. Now looking at still on the ambient here, we look right here at the Valvoline Restore and Protect ambient and the percent difference of that between Valvoline Restore and Protect and Walmart SuperTech. It's only a 2% difference. Again, insignificant, within variation of, 10, 20%, whatever you want to use. The industry standard usually for error is 20%. Well, life science, that is. But in typical biological plate-based assays, now you're talking, say, HPLC or something like that, it could be as little as 2%. So, well, it still is a insignificant difference based on this report, but however, it still, I think, is just useful to see how this works out. All right, now moving on to the heated test. Now, this is where things go exactly in the opposite, and I'm not sure, and it was consistent, and that's the whole thing here. Now, if you look at the Valvoline Restore and Protect, its viscosity went down a little bit, and so there was less grams. Yes, that's that's a difference. I mean, we'll look at those differences in a second, but that's a difference from the ambient. Now we move on to this is where it gets a little weird at with the Walmart SuperTech 5W30. We had an increase in weight. Now, that does not mean the viscosity did not go down, because technically we do not know the density of these oils because we don't know what molecules are floating around, and we're just going strictly on viscosity. For example, if you look here at this chart right here that I have, this is for 5W40, but it's just to say that when temperature increases, viscosity goes down. So standard reason, if something has more viscosity, less of it will cling because it will be much more liquidy and flow off. And also the density also goes down as well. That density goes down as a function of less liquid being present and clinging because the viscosity, these molecules are moving faster past each other, if you want to think about it that way. And also you got to account for when temperature goes up, expansion. Well, that's probably the reason why the density goes down, because expansion of an oil or a liquid or say water happens, and that means there's more space. So if you have, say, 5 molecules, let's just make an example. And let's say we have 5 molecules in 1 milliliter of water, and you heat that 1 milliliter of water up and it expands to say 1.5 milliliters. You're still going to have that same 5 molecules in that liquid. However, this density is decreased because there is more space available for those 5 molecules. So that's why this is interesting here, why these heated results did this. Now, if you move on to the SuperTech 0W20, there's even a bigger difference. Now, I was shocked when I saw this because first I thought, this is no lie, when I saw this, I thought, okay, maybe I messed up somehow and it got the 5W30 for the SuperTech. Just kind of, because it was kind of, I'm doing this manually, and I tell you the thing is trying to control for what actually drips off in the movement of your hand. It really was hard to do, but I felt like I was as consistent as I could be with it. But still, got the result, and it's very similar in a certain sense to what the difference is between the SuperTech 5W30 ambient and heated. Now, moving on to the AC Delco, there's even, it's the same size difference about as the 0W30, but that's even bigger than the 5W30, which again, you would think that it would have more grams just because it's more viscous, but how much difference in the percent would it be? Now, again, don't forget, we can't account for density because we don't know the additive packages. We don't know what's in here. We can say what I think I can say, correct me if I'm wrong. The gear oil would not have a lot of, say, the cleaning agents and other things that a motor oil would have because, well, there's no carbon, there's no gasoline, there's the only thing it has to worry about is more or less anti-friction, anti-wear, anti-foam, and maybe there's some other things I don't know about, but generally speaking, a gear oil and an engine oil should be different in composition added to package because, again, well, you don't need, and I think gear oil a lot of times have more sulfur in it, maybe. I'm not entirely for sure about it, I think. Not entirely for sure about that, but correct me if I'm wrong on that. So looking at the percent difference between the heated Valvoline SuperTech 5W30 and the heated Walmart SuperTech 5W30, there's a 55% difference there. Now, that's significant. Again, somewhat expected because I thought one might be more than the other, but I ain't gonna say expected that much. But again, these results, not saying that they are necessarily real, but it's kind of odd that all the oils were consistently high other than the Valvoline SuperTech 5W30. Now, looking at the ambient versus heated in the last, what is this table here? Looking at the percent difference of 5W30 against itself, ambient versus heated, there's a 13% difference. That's not, I would say, necessarily outside of what would be considered significant, but I think it's getting there. It does suggest that definitely there is a difference without a doubt. With the Walmart SuperTech 5W30 heated versus ambient, there's a huge difference in between those oils. 45% difference in the weight that this is just by weight. So again, we're not looking at viscosity or density. So that's why this test is just a quick and dirty test. Again, not necessarily anything to read into, but still interesting nonetheless. Walmart SuperTech 0W20 ambient versus heated, 68% difference in the weight that was carried over on the steel rod. That was that was unexpected. All three of these unexpected, but this is super unexpected because I thought I was going to get something much lower than that. AC Delco gear oil, again, super surprised by this result. And their results are what they are for this test. Again, this is just for entertainment purposes. You can take them all with a grain of salt, but I really enjoyed doing this, and I think I might proceed with doing my next test. So anyway, let's take a look at what I got for the conclusion really quick. I'll read it out. It said the initial trend of the ambient viscosity behaves as expected, although there's minor differences. I mean, it's kind of what I thought might have happened. The VRP 5W30 viscosity doesn't have any significant change. You know, that's basically saying the heated versus the ambient. Unexpected and significant changes in viscosity of Walmart SuperTech and 0W20 and in the AC Deco 75 when heated. So that's the heated versus I didn't say that here, but I should have made that clear. The heated versus the ambient, super significant. The percent difference for ambient Valvoline Store Protect when comparing that to ambient Walmart SuperTech 5W30 oil is not really significant. That's only about a 3% difference. And the percent difference when you have Valvoline Storm Protect 5W30 versus Walmart SuperTech 5W30, that is a significant difference, a huge significant difference of 55.3%. Wow, I gotta say, surprising, striking results, but at the same time, don't take any of this as face value, or not necessarily face value. Don't take it as anything as deep or scientific, because it's not, but at the same time, interesting. So anyway, before I go, here's a picture of the lab setup I had today. I hope you guys enjoyed not only the video, but seeing how I got my little lab set up here in my garage and that sort of thing. So with that said, let me know down in the comments how you guys like this video. Please give it a thumbs up. It took me a little effort to make this video, and just giving a thumbs up, even if you don't subscribe, I wish you would subscribe as well. But even if you don't do nothing, just give it a thumbs up. It really, really helps me out. And trust me, it makes me, encourages me, and makes me want to do more things like this. And trust me, I do have another experiment lined up. Just give me several weeks and to get the things that I need and just to flesh it out. And we'll see how that goes. You guys take care, and I'll see you in the next one.